everyone. My name is Belinda Vennam. I'm visiting here from North Carolina, so it's my first time in Atlanta in quite a few years. I really liked, visiting the aquarium, so thanks to all the organizers for putting that together. So I'm a software developer and dev advocate at IBM. I have some contributions to the Apache OpenWhisk project, and more recently, I've been spending a little bit of time with a new project called Knative. It's a pretty exciting technology in the Kubernetes community, so I'd like to spend a few minutes just sharing that with you guys today. Has anyone here heard of Knative? Okay, so maybe 8 to 10 people, awesome. So for those of you who have heard of it, I'm hoping that you'll kind of start to build a little bit of a deeper knowledge today, and for those of you who haven't, I'm hoping that you should walk away with a really good overview of the project and kind of what the project is hoping to bring to the Kubernetes community. So we'll go ahead and get started. So we'll start by talking a little bit about how we arrived at serverless. So in the past, when I'm ready to put my code on the cloud, me or someone else in my company might have needed to purchase bare metal servers, right, to run my application on. You'd have to manage the security updates for those servers, install all the required software, and keep the hardware up to date as well. As virtual machines came into the picture, we were able to let someone else, like maybe Amazon or Rackspace, manage those machines for us. And we would just get that virtual machine to run our application on. So you'd still have to manage the operating system, maybe some software dependencies as well, but you didn't have to physically own or house those servers anymore. Even more recently, we've had containers enter the scene where we're literally only managing the application code and its dependencies. So we just package everything up into that container, hand it over to the platform to be run. So that made things a lot easier, but there's still some management of infrastructure that's happening there, right? We need to manage our own runtime. We're managing our own application dependencies. Building a container to run your application is still a little bit of a manual process that could be abstracted away. So we want software developers focusing on that business logic, right? That's the sell of serverless. We don't want them distracted by infrastructure management or configuration. And those abstractions are ultimately what serverless or functions as a service offerings bring, right? The execution environment for the code is provided for me. And my code just gets run maybe in response to some events or actions that I care about. So I should note, I'm kind of positing this as an evolution, but actually all these models are still available today, right? And they might even be the right choice, kind of depending on what problem you want to solve. So I have on the x-axis it says decreasing concern over your stack implementation, but that's also going to come with decreasing control. You have to wait for the platform to make any of the required updates. So if you do need that additional control, one of the others might be the right solution for you. I just think this is another nice way to kind of visualize those increasing levels of abstraction. So as we're moving through each of those deployment models, like on-premises, infrastructure as a service, container as a service, to functions as a service, you're seeing that there's less and less that the end user is ultimately responsible for. So we talked a little bit about how we got to serverless, but I just want to quickly level set on some of the benefits that serverless is hoping to bring to developers. And I know these were covered to an extent from some of the other serverless track speakers, so I'll try to roll through these really quickly, but I just want to make sure we're kind of all on the same page. The first one, we say, okay, no servers. There are servers somewhere in this stack. You can go on Twitter and argue about how it's an awful name, but ultimately we're abstracting away the management of those servers. Like we say, you want to focus just on the app or the business value, not on configuration and server management. Scalability, so we want the platform to handle scaling our application out when we're under load. So maybe you have some backend APIs. Each endpoint may be represented by a serverless function, and one of those endpoints might see a sudden spike in traffic. So you want this serverless platform to actually scale out that endpoint or that function for you. We talk about scaling our app out to n instances, but we also want it to scale back down when it's no longer in use, so scale it back down to 0. So you can imagine maybe you have a payroll app that only gets run once every 2 weeks or once every month. So we want that app to scale back down when it's no longer being used and to stop charging us for those resources, or maybe to reallocate those resources for another application. Event-driven scenarios. So most serverless platforms are going to support some kind of event-driven programming paradigm. So that's just reacting to incoming events with running some kind of code. So a couple of examples, you could imagine you have an application, maybe you have your users upload their profile image, and you want to store that in an object store. As soon as that gets stored, you want to run some code to generate a thumbnail to be used kind of throughout the site or throughout the application. You could imagine like if you're creating a review app, maybe the next Yelp, you have your users inputting some text, that text gets stored into a database, you want to react to that by maybe running some sentiment analysis, and that sentiment analysis could be your serverless function. The final one I have up here is easy integration with cloud services. So you have to think when you're using a cloud platform, they have a big incentive to get you to try out those other services, right? So that can be things like artificial intelligence or their object storage or database services. So kind of as you're thinking about the various serverless platforms, also think about what services are easy to connect to or easy to integrate in with that as well. And then ultimately, all of these things kind of combine together to make a decreased time to market. That's kind of the ultimate goal of serverless, or one of the goals. So I like this quote from serverless.com, and it says that serverless abstracts away the most menial parts of building an application, leaving developers free to actually spend their days coding. And I think that's the dream, whether that's ultimately true or not, I guess it depends, but that's the dream. So a ton of companies have serverless products that are attempting to kind of meet that set of goals. So Google has serverless containers on Google Cloud Functions. IBM has IBM Cloud Functions. There's Pivotal Functions Service, Red Hat Cloud Functions. And with each of these products going off and building their own implementation, there's actually a lot of duplicated effort, right? As well as the possibility for vendor lock-in or lack of portability for the end users. So a few of these companies, Google, IBM, Red Hat, Pivotal, and some others were able to come together and say, hey, we're all building these various elements of a serverless platform, and we should actually be able to pull out some of those elements as repeatable building blocks that other, our own serverless platforms or other serverless platforms could then be built on top of. So you can see those three sort of building blocks at the bottom. Those are the Knative primitives of build, serving, and eventing. And we'll go into each of those in a little bit more detail later. So Knative is built on top of Kubernetes and Istio. Developers can definitely use it directly, but ultimately the most user-friendly experience is going to be to use a product that's built kind of on top of Knative or a product that's Knative compliant. It's an open source project, which is really exciting. It's at release 0.4, I believe. So that number should indicate something to you, right? It's not at 1.0. So there's a lot that's still moving and changing. So I think it's going to be interesting to kind of see how some of the current products shift or align to Knative. In fact, I believe at the Google conference, they just released a product around Knative this morning, I saw on Twitter. So some interesting stuff happening there. So does anybody here have experience with Kubernetes? Okay, so roughly half. Is anyone using Istio or has some experience with Istio? Okay, like 4 people. Okay, perfect. So we'll kind of cover those a little bit, and then we'll jump into some more details on Knative, and then I'll do a demo. So just kind of give you an idea of where we're headed. So containers are this kind of other technology that's promising greater ease of application, development, and deployment. And there's also a ton of developers in that space. It's kind of been building alongside serverless in some ways. According to this survey from logs.io, over 60% of developers are using container orchestration services. But we also have a ton of developers using serverless, right, in their application logic. And there's a lot of excitement there too. So we know there's a big value add with serverless as well. So Knative is in part attempting to bring those promises of serverless that we talked about over to that big portion of developers who are using container orchestration services in their project. So it's kind of attempting to bridge that gap. So I'll quickly do just a few definitions. Like I said, I like to kind of ensure everyone's on the same page. And I think it's important for you to understand the landscape that Knative is built on top of. So a container, like I said, is a standard way to package up an application and all of its dependencies, so you can easily move it between environments without changes. A really good analogy for this, and one I'm sure you've seen, is shipping containers. So with a shipping container, you could literally throw anything you want inside there. You could put your lamp, your bed, your refrigerator, whatever, inside of a shipping container, and you end up with this nice rectangular prism-shaped thing that you can just put on a boat or on a shipping pipeline, and it's just going to work. Containers are the same. So you can just take your application, all the environment dependencies, shove it inside there, and if you just hand it over to Docker or a machine that has Docker, it's just going to run. So as long as everyone else has Docker installed, they can run your application and any other Docker containers without those environment changes. So containers were great. Like I said, they solved a lot of those environment and dependency issues when you only had one or two to manage. You just build the container, you deploy it, boom, it's running. You can share it with your friends, with other people at your company. But what happens when your application has hundreds of microservices? Maybe each of those microservices have multiple different instances, right? You might have tests, development, staging, production. What happens if one of those containers die? So how do you deal with this explosion of up to thousands of containers to ensure that they're being managed properly, that they can scale, that they're being scheduled properly, that they're able to communicate with each other? That's where container orchestration platforms came in. So container orchestration tools enable a number of different things. So one of those is scheduling. So how do you ensure that your new container is scheduled onto the right VM? So a container orchestration platform like Kubernetes can automatically look at the resource definitions for your containers, find that CPU-intensive app, find the memory-intensive app, and then co-locate them to ensure that max utilization of infrastructure. Things like service discovery. So how do the containers find one another and talk to each other? In Kubernetes, a service can register itself with a lightweight DNS, and that allows other services to find them easily and dynamically. Things like monitoring. So how do you monitor the health of all of your containers? If a container goes down, container orchestration platforms can detect that and then restart the service or redeploy the pod. And then configuration management. So how do you effectively push out configurations like credentials to each one of your containers? So these are all things that Kubernetes aims to solve as a container orchestration platform. So yes, Kubernetes made managing containers easier for developers, but as people started to move their microservices there, we started to see a whole new set of challenges for managing those microservices on Kubernetes. So these are some more challenges, right? Things like security. So how do you encrypt traffic between each of your microservices? How do you know that your microservice is talking to the right other microservice? What if someone maybe injects a new pod in your cluster and then you have a man-in-the-middle attack? How do you roll out a new application version to a small subset of the users? How can you test how your system is going to behave if one of the microservices fails? So these are some of the kinds of features that are provided by a service mesh. The first-class citizen of a service mesh is a service, and then it provides a network for connecting, observing, and securing those services. Excuse me. So Istio is a really popular open source collaboration. It's founded by Google, Lyft, and IBM, and it now has over 20 other companies contributing to it. So it's trying to position itself to become the de facto way to do that connect, manage, observability, and security for your microservices on top of Kubernetes. So Istio provides those features without making changes to the application itself. It does that by running proxies next to each of the microservices. Those proxies intercept the traffic, then provide whichever functionality without the application actually knowing about it. So I know that's a really 10,000-foot view on Kubernetes and Istio. I think each one of those could be their own 1 hour long talk, but I did want to share a little bit about them because Knative is built on top of both, right? And by being built on top of both Kubernetes and Istio, Knative is able to utilize functionality from them, and if you're using Knative, you're able to kind of peel back the layers and get access to those underlying open source layers if you need to. So we talked about some of these concepts so far, but I think that these quotes are really good for describing Knative and helping us to understand where it fits in the big picture. So the first one is from the docs, which is a really nice place to start if you want to start learning about Knative. And it says that it's a Kubernetes-based platform to build, deploy, and manage your modern serverless workloads. So as I said, it's bringing that serverless functionality to a Kubernetes cluster. Knative it's got that goal of bridging that gap between clusters and containers and serverless. The second quote is from Oren Teach, who's one of the product managers over at Google. And he says that it's an open source project that provides the building blocks for serverless. So I think he's kind of coming at, they're really envisioning companies building on top of it. They're seeing it as a foundational layer. So they want companies to build on top and build like a full serverless platform or offering. Jason McGee, one of the VPs over at IBM, echoes something really similar, saying that we anticipate Knative becoming a foundational component for serverless architectures that can take advantage of all types of cloud-native tools. And then ultimately, Knative is just some custom resource definitions built on top of Kubernetes and Istio. So for those of you who don't know what a CRD is, it stands for Custom Resource Definitions, and it's actually really well named. That's not always my experience with tech stuff, that it's always really well named, but this one is. So this is a feature of Kubernetes, and it allows users to add their own or custom objects to a Kubernetes cluster, and then use it like any other native Kubernetes object. So things like deployments, pods, or services. So when I show a quick demo of Knative in a couple of minutes, I'll actually use the Kubernetes CLI for a part of it, and that's because Kubernetes knows all about those Knative objects. So if you don't know a ton about Kubernetes, I really suggest going and checking out the Phippy and Friends books. This image is pulled from there, and it gives just a really nice explanation of different Kubernetes concepts, but written as like a children's storybook. So they have these really cute illustrations, and they help you to kind of start understanding all those Kubernetes concepts. In this one, Phippy's going to the zoo, and she sees the CRD pen, and it's got some peculiar custom-made critters: a giraffe with a hippopotamus head, a snake with raccoon ears, and a unicorn with no horns. So they're all these custom like zoo critters, but they're still animals in the zoo. So each of those Knative primitives that we talked about before define some CRDs to extend Kubernetes. So we'll jump into each one of those primitives a little bit now. So the first one is Knative build. Knative build supports building your container images from source code. That container can then be stored into a container registry, so something like Docker Hub or IBM CR or Google CR, and then the application could then be run using Knative serving. And then I did put a caveat up here that this space is really changing very rapidly. The whole project is. So one thing to maybe check out is Tekton. So you can do that on your own time. Knative serving. So Knative serving is what's going to provide a lot of those promises or features of serverless that we talked about earlier. So automatically scaling your application up or back down to 0 when it's no longer being used. Handling some of the routing and network programming for your application. Tracking point-in-time snapshots of your deployed code. And then, of course, like rolling upgrades. So things like traffic splitting or A/B testing. So these are some of the CRDs that Knative serving provides. There's a route, and that's what handles the network endpoint for your application. That route will be mapped to one or more revisions. A revision is just that point-in-time snapshot of your deployed code. Revisions are immutable objects, so anytime there's a new configuration change, you'll actually trigger a new revision to be created. And then finally, service, which I want to highlight because applications in Knative are represented as a service. And then eventing. So Knative eventing is a system that's designed to address that common need that we talked about for serverless platforms of like producing and consuming events. Their goal is to make it really easy to create event producers and consumers. They provide a couple of different CRDs. I just wanted to highlight these two. There's a Kubernetes event source and a GitHub source. So with the GitHub source, you could imagine like reacting to a GitHub event. Maybe the event is a new push to master. which might kick off your container build, right, using Knative build, and then ultimately you could use Knative serving to then deploy that built container. Okay, so we'll see all this a little bit in action. I'm going to try to do this live. I've been having some trouble with the Wi-Fi today, so hopefully this will work. The first thing that I'll kind of have 3 parts to the demo. So the first thing we'll do is deploy a container that already exists. It's on Docker Hub. We're just going to deploy it to Knative. We'll use kubectl and a YAML file. So for the Kubernetes users, that should feel very familiar. For the second piece of the demo, rather than deploying a container that lives out on Docker Hub, we're actually going to go ahead and build it from source code. So we'll build the container and then deploy the container to Knative, again, using a YAML file in kubectl. And then finally, for the third part, we'll check out knctl. That's, again, a new tool for interacting with Knative. So it's hopefully going to start to simplify some of that development experience. Cool. So let's see. Probably have to mirror. Oh, cool. I think it's already mirrored. Awesome. Okay, so I just wanted to show you guys the application really quickly. So I'm going to click on server.js. Can you guys see that, or does it need to be? Can y'all see that? Okay. Sorry, I'm not used to it being this big. Okay, cool. So this should look pretty basic. It's just a Node.js with Express app. It's got this endpoint. We're going to hand it a number, and then it's just going to return that many elements of the Fibonacci sequence. So if we hand it 3, it should return like 1, 1, 2. If we hand it 4, it should return 1, 1, 2, 3. I won't go much higher than that. And then the other thing I wanted to highlight in here is that we have a Docker file. And this is what's defining the container that we want to build. Again, this is pretty basic. So we're just pulling the Node Alpine image, and then we're going to grab our dependencies, and then do an npm install, and then npm start. So that's just going to start up the app. And then the other thing I want to show you guys before we start, I also have this container image already pushed up to Docker Hub, so that's the one that we'll use to start with. Okay, and then this probably needs to be a little bigger too. Oh, doesn't like that. Oh. Okay, can y'all see that, or should it be a little bigger? Okay, okay. I don't know how this is all going to look being this big. I should have tried that out. Okay, better? Okay, cool. So I have my little commands over here just to keep me on track. The first thing we want to do is check out the YAML file that defines our app. And so you can see I'm creating a service. Like we said, that's kind of the equivalent to an application in Knative. And this first one, it's a lot of boilerplate code. I'm naming my service as fib knative, putting it in the default namespace, and then I'm just going to go out and grab this container image that already lives on Docker Hub. So I can just do a kubectl apply, and then apply that. And then we'll do a get pods. So we'll watch our pods created. They're probably already, yeah, so they're already running because that one's really quick. And then we can just curl this URL where the application lives. I should note that on IBM Cloud, the Knative add-on actually goes ahead and does some of the network programming for you. So if you deploy an application, it just goes ahead and gives you a URL and does that Istio ingress routing for you. So we automatically get a URL. And you can see it returned 112 over here. Do you guys see that? So that's kind of what we expected to see, the first 3 numbers. We can try the first 20 numbers, and it's going to return those to us. So perfect. That's what we expected to happen. For the next one, we'll just take a look at building the application from source code. I forgot what my file was called. Surface.yaml. So this is a little more complex, right? It's another YAML file. You can see some of the same elements. So we are creating a service. We're naming it fib knative. Got a couple of other things in here. So we're bringing in build. I'm providing some service credentials. So that's so it can have access to my container registry. And then you can see I'm going to provide it with this get URL. So that's where the application lives. And I'm going to tell it, hey, I want you to go and grab the master revision, pull that down, build it, and then deploy the container. Oh, and I should also point out really quickly, for this one, instead of Docker Hub, I'm going to use the IBM Cloud Container Registry here. So that's where the container will get stored. Okay, so if I do a kubectl apply service.yum, and then we can actually watch the pods get created if I could type. Okay. So you can see it's creating a second revision. This one should take a little longer because it's going out to GitHub, it's grabbing the source code, going to build the container, and then after it builds that container, it's going to put it in the IBM Container Registry, pull it down, and then deploy it to Knative. So we can actually check and see, make sure that our container was created. So if we do an IBM Cloud CR image list, hopefully. There it goes. Yep, so 22 seconds ago, that's our container, if I could highlight it, that got deployed out to the container registry. And then, of course, we can curl this image. So clear that. And again, we're getting 112. Yeah, however many you want to do. Perfect. So we just built the container and then deployed it. Does anybody see anything wrong with this version of the Fibonacci app? So I'll do just the first 3 numbers. Anybody have a problem with that? Any math nerds? No complaints? Okay, well, it's starting with 1 instead of starting with 0. So if you're a purist, you might argue, hey, the Fibonacci sequence should actually start with 0. So let's pretend that we have a vNext version of the application, and this one instead is going to start with 0 instead of 1. To deploy that vNext application, I'll actually use knctl. So rather than using a YAML file and kubectl, we'll use the Knative CLI, so knctl. So we can just do this knctl deploy command. You can see it's going to do a lot of the same things. I'm handing it the service name, the get URL where my application lives. Instead of revision master, I want revision vNext. That's where the code lives to start with 0 instead of 1. And then some service information to access the container registry, and then, of course, the image where I want it to live. One of the cool things that knctl does, it's going to tag my newest revision as latest, and my previous one as previous, so we can actually use those tags from the command line after that. So let's see. It says it should be up and ready, so we can go ahead and curl it. Okay, I think I'm running out of time. I'll try to hurry up. I did start late. Okay, cool. So it's starting with 0 instead of 1, so that's perfect. So I'll kind of quickly roll through these just so you guys can see. So we can do a rollout. So if we want it to put 50% of the traffic to latest and 50% of the traffic to previous, we can do that using the knctl rollout command. And then we'll just confirm that that worked using a routes list. So we can see, yep, it's doing 50% to each version. And then we'll just do this really quick while loop. So this is going to constantly curl against that URL. And so hopefully we should see like about 50% of 0 and 1s, because I'm just calling it with a /1, so I'm getting the first number. Yeah, it looks like it's approximately 50%. Sweet. And so if we leave this kubectl get pods watch up here, after a while, we should see the revision 3 spin back down to 0 because we've stopped using it. So I think that takes like 1.5 minutes, so we won't sit here and wait. But I do want to just kind of quickly wrap up for you guys. Sweet. So we did our demo. So as I said, Knative is this really brand new project, but it's bringing in the experience from a number of key players, and I think it's worth watching. Google's in there, IBM, Pivotal, Red Hat, SAP, ton of others. And each of these companies is bringing in their experience, right? They've had experience building these serverless platforms. I mean, they're kind of donating this experience into this shared project that the open source community can benefit from. So I think that by working together in the open, we can avoid duplication of effort, as well as continue to advance serverless in general, as well as the serverless experience on Kubernetes. So a couple of links. You can follow me on Twitter, ask me whatever. You can go be a contributor on Knative, so github.com/Knative. Maybe start with the docs. It's a good place to always start. And then if you want to try out this demo on your own, I have some instructions at the third link, and then there's my email address. So thank you so much.